Everyone, welcome back to my online teaching platform. We are still on application of differentiation in relation to tangent and normal to a given curve. Right, we have our seventh question here. The question is find the equation of the tangent. Find the equation of the tangent to the curve y is equal to x squared minus x minus 2 at the point where the curve meets the line y is equal to x plus 1. So we are to find the equation of the tangent to the curve at where the given curve meets the line y is equal to x plus 1. Alright, so let's look at how we are supposed to answer this question. Alright, so if you have a curve and a curve meets a line, it means they have a point of intersection. And at that point, you have to put or indicate your tangent over there. All right. So the curve has 2 points of intersection with that of the line. All right. So you have to find the equation of the tangent at those particular points. Now, how do you determine those points of intersection? All right. If you have two equations or two functions, if one is a linear function and one is quadratic, and you have to find the point of intersection, what you are supposed to do is to solve the two equations simultaneously. So when you solve the two equations simultaneously, you are going to get two x values and their corresponding y values. So you are going to get 2 points, right? So those points are the point of intersection of the line given and that of the given curve. So we have a curve to be y is equal to x squared minus x minus 2. And you have the line to be equal to y is equal to x plus 1. Alright, so this is our line and our curve is y is equal to x squared minus x minus 2. Now we are to find the equation of the tangent at where the curve meets the line. So we want to know where the curve meets the line. So we have to find the values of x and their corresponding y values so that we'll be able to determine the point where the line meets or the curve meets the line. All right. So we solve the equations. So we are going to solve the equations simultaneously, right? So we have our first equation to be y is equal to x squared minus x minus 2 as our equation 1. Then we have y is equal to x plus 1 then as our equation 2. All right, sorry, the first one is rather our equation 1. So this one becomes our equation 2. All right, now in equation 1, you can see that we have the value of y to be equal to x plus 1. So we are going to substitute the value of y in equation 2 into equation 1. All right, so we substitute the value of y in equation 2 into equation 1. All right, so let us continue. We are going to get wherever you see y in equation 1, you put the value of y in equation 2 over there. So y is equal to x plus 1 in equation 2. So we are going to get x plus 1 is equal to x squared minus x minus 2. All right. So let us transpose the terms at the right hand side to the left hand side. You're going to get x squared minus x. When you transpose this particular one, it becomes negative x, so minus x again. When you transpose this one, it's going to be negative 1. So minus 2 minus 1 all equals 0. Then we have x squared minus 2x, then minus 3 all equal to 0. This becomes our quadratic equation, right? So we need to find our AC. So A times C. A is the coefficient of x squared. So 1 times the constant term, negative 3. You are going to get negative 3. Then you identify two factors of negative 3. That when you multiply, you get negative 3. But when you add, you get negative 2. All right. So what do you think are the factors? The factors are negative 3 and positive 1. When you add negative 3 and positive 1, you're going to get negative 2. When you multiply them, you are going to get negative 3. Right? So we are going to now write it as x squared. Then you replace the negative 2 with negative 3x and positive 1x. So which is the same as x. So you will say that negative 3x plus x give us, you are going to get back to the negative 2x. Then you bring back your negative 3, all right, all equal to 0. Then you now put them in pairs. So x squared minus 3x in one bracket plus x minus 3 in another bracket, all equal to 0. Okay. Then here we have to identify the highest common factor, which is x. So we are going to use the x to divide all of them, and that will be x minus 3. In the second bracket, the highest common factor is positive 1. Then we have x minus 3 here, all equal to 0. Now put the factors in one bracket. So it's going to be x plus 1. Then you repeat one of the equal bracket, which is x minus 3, all equal to 0. So this will give us x plus 1 equal to 0. Then we solve for x. X is equal to negative 1, or x minus 3 equal to 0. Then this will give us x to be equal to positive 3. All right. So these are the values of x, but we need to determine their corresponding y value. So we take when x is equal to negative 1, then you find its corresponding y value. So we can pick one of the equations or one of the functions. So let us use the linear one so that it will be very, very simple. Okay, let's use the linear one, then it will be very, very simple. Then we have x plus 1. So whenever I see x in this equation, put negative 1 there. So y is equal to negative 1 plus 1. And that will give us a result of 0. So the first point of intersection becomes negative 1 against 0. All right. Negative 1 against 0. Okay. So let us continue and look at the other aspect too. Then for the other aspect, let us look at how best you can get that one too as well. When we have when x is equal to when x is equal to 3, let us look at how best you can get it. So x is equal to 3, you are going to get our y equal to x plus 1. You are going to get y to be equal to 3 plus 1. And that will give us a result. This implies that y is equal to 4 when x is equal to 3. So we have x value giving us a y value of 3, sorry, 4. So we are going to get 3 against 4. So this is one of the points where the line or the curve meet the line given. All right, so we are going to work with these 2 points. Okay, we are going to work with these 2 points. The first point is having coordinate of -1 is 0. So, and the second one too is having a coordinate of +3 and +4. So these are the points that we are going to work with. All right. Okay. So now let us find the equation of the tangent at this point. So equation of the tangent at, so I'll go for the first point at the point with coordinate of -1 and that of 0. All right. So we have to find the equation of the first gradient, sorry, of the first tangent. Sorry. So it means we are going to get two tangents. Okay, we have two tangents because the point of intersection of the curve and that of the line are 2. So it means if you are to find the tangent, the equation of the tangent at those points, that's the point where the curve meets the line. And we have 2 points where the curve meets the line. So we need to find the equation of the tangent at those 2 points. So we pick one point, then you find the equation of the tangent. When you are done, then you pick the other point and do the same thing. All right. So we are now dealing with the first point. Now we need for any equation of a straight line, we need gradient, we need our gradient and that of a point. So we need just two things, then we can find the equation of a straight line. Okay. So let us find the gradient. We know that at the point where the tangent touches the curve, the gradient of the tangent and that of the curve will be equal. All right. So let us find the gradient of the curve at the point where the tangent touches the curve. So we are going to get our gradient function to be dy dx. All right. So we have our function to be y is equal to x squared minus x minus 2. So dy dx will give us 2x minus 1. And we have the x coordinate at that point to be -1. All right. So when x is equal to -1, our dy dx, our dy dx will be equal to 2 multiplying -1 minus 1, and that will give us a result of -3. So we can now find the equation of the tangent at the point with coordinate -1 and 0. All right. So let us now find our equation, which is y minus y1, because the tangent is a straight line. Then equal to the gradient of the curve at that point, which is the same as the gradient of the tangent at that point, multiply x minus x1. Right. So we have y minus the y1. So the y coordinate of the point where the tangent touches the curve is 0, equal to the gradient, which is -3, multiplying the x minus the y, sorry, minus the x coordinate of the point where the tangent touches the curve. So that is -1. All right. So you'll be getting y to be equal to -3x. Then here will be -3. All right. So we are going to get y to be equal to, or y plus 3x plus 3, or equal to 0. All right. Or you can equally write it as, y plus 3x equal to -3. Okay. So this is the first equation of the tangent. Now we look at the next one. Okay, so we are going to pick the next point, the other point, which is, I think the other point we had, okay, 3 against 4. So equation of the tangent at point with coordinate 3, 4. All right. So we are now finding the equation of the tangent at this point. So you find our gradient function again, dy dx, which is the same as the 2x minus the 1. All right. Then at x equal to 3, our dy dx will be equal to 2 multiplying the value of x, which is 3, minus 1. And this one will give us a result of 5. All right. A result of 5. So this becomes the gradient of the tangent at that particular point. Okay. So let us find the equation of the tangent at that y minus y1 equal to the gradient multiplying x minus x1. All right. So we know our point to be 3 against 4. So we have our x here, which is the x1, and we have our y1. All right. And we have our gradient also to be 5. Okay, so we are going to get the equation to be y minus the value of y in the point where we are to find the equation of the tangent. So the value of y is 4 minus 4 equal to the gradient multiplying x minus the x coordinate of the point where we are finding the gradient. Sorry, we are finding the equation of the tangent. That is 3. Then we are going to get y minus 4 is equal to, we expand the bracket, we are getting 5x minus 15. All right. Then we are going to get y minus 4 plus 15 minus 5x equal to 0. Then we will be getting y plus 15, okay, y minus 15, then plus 11, all equal to 0. So this becomes the second equation. So this becomes the equation of the second tangent. All right. So it means we have two tangents. So this is one of the equations. Okay, let me circle it. Okay, and we have already worked on the other one. Okay, so let us go back and look at the first one that we did. Okay, the first one, this is what we got. Okay, all right. So anytime you have a question in this form where a curve cuts or a curve meets a line, and you have to find the equation of the tangent at where the curve meets the line, it means you need to find the point of intersection of these two functions. So you have a line and a curve. So the curve meets the line at 2 points. All right. How do you determine the coordinate of those 2 points? You have to solve the two equations simultaneously. All right. Then when you get the value of x, you now substitute each of the values of x into the equation, any of the equation. You can use the curve or the straight line to get the corresponding y value. Then you pick each of the points to find the equation of the tangent at that particular point. All right. So